Okay, let's get started. Right. Today, I want to talk about the way in which we are able to determine how the people run or some other geological features, dating techniques. I'm going to talk about a particular dating technique. Why? Good dating is a key to good analysis. In other words, if we want to know how the land formation was formed, the first thing you probably want to know is how old it is. That's fundamental. Take the Grand Canyon for instance. Now, we geologists thought we had a pretty good idea of how the Grand Canyon in the southwestern United States was formed. We knew that it was formed from sandstone that solidified somewhere between 150 and 300 million years ago. Before it solidified, it was just regular sand. Essentially, it was part of a vast desert. And until just recently, most of us thought that the sun had come from the ancient mountain range very close by, flattened out over time. That's been the conventional wisdom of the geologists for quite some time. But now we've learned something different and quite surprising, using a technique called uranium-lead dating. I should say that uranium dating that have recent refinements. I'll get into in a minute. Anyway, uranium dating has produced some surprises. Two geologists discovered that about half of the sand from the Grand Canyon was actually one part of the Appalachian Mountain. That's eye-opening news, since the Appalachian Mountain range is, of course, 1,000 kilometers to the east of the Grand Canyon. Sounds pretty unbelievable, right? Of course, the obvious question is, how did that sound end up so far west? The theory is that the huge river and the wind carried the sound west. Their mixed with the sound was already there. Well, this was a pretty revolutionary finding. And it was basically because of reality dating. Why? Well, as everyone in this question clusters know, we usually look at the grain type within sandstone, meaning the actual particle in the sandstone, to determine where it came from. You can do other things too, like look at the wind and water that brought the plant into their location to figure out which way it was flowing, but that's all useful at the point. That's not what the two zeros. The uranium detonating allowed to go about the entire different way. What they did was they looked at the grains of zircon in some zircon materials that contain radioactive uranium, which makes it very useful for dating purposes. Zircon starts off as molten magma, hot lava from volcanoes. This magma then crystallizes. And when zircon crystallizes, the uranium inside it begins to turn into lead. So if you measure the amount of lead in the zircon grain, you can figure out where the grain was formed. After that, you can determine the age of zircon from the datum mountain range, and once you do that, you can compare the age of zircon as a sandstone in your sample to the age of zircon in the mountains. If the age of zircon matches the age of one of the new mountain shells, then it means the sandstone actually used to be part of that particular mountain range. Is everybody with me on that? Good. So in this case, uranium dating was used to establish that half of the sandstone in the sample was formed at the same time as the ground in the Appalachian Mountain. So because of this new way of doing uranium dating, we've been able to determine that one of our major assumptions about the Grand Canyon was wrong. Like I said before, uranium dating has been with us for a while, but until recently, in order to do it, you really had to study many individual grains, and it took a long time before you got a result. It just wasn't very efficient, and it wasn't very accurate. But technical advances have cut down the number of grains you have to study, so you get your result faster. So our predict is that the uranium dating is going to become an increasingly popular dating method. There is dating. Here's one that comes to mind. You know the theory that the Earth's continents were once joined together and only split apart relatively recently? Let's see, read dating, we could prove that more conclusively. Because they showed evidence once having been joined, that could really tell us a lot about the early history of the planet's geology. Planet geology. What does that you can determine the age?